Are you tired of staring at your failed casts or wondering what to plug into the object input? For years, blueprint communication felt like an unsolvable puzzle to me, but after plenty of trial and error, I finally figured it out. It all comes down to 3 essential concepts that will make everything click. But before we dive deep into those 3 concepts, let's cover the basics first. Blueprint communication always involves a sender and a receiver. The sender sends out a signal and the receiver acts, like opening a door, for example. The first concept I'll tackle is the one you've probably been using the most so far. It's direct communication. This is when one blueprint is directly talking to another. The sender gains access to the receiver to do things like calling a function, getting variables, or just updating variables. What's important to understand is that this is one-to-one communication and not one-to-many. Therefore, you need to know which receiver you're trying to communicate with. You can achieve direct communication in 2 ways. You can reference placed actors, and you use this when you have 2 blueprints already placed in the world. So here I have a sender blueprint and a receiver blueprint. In the sender blueprint, I'm making a variable of the type BP receiver. So that's the blueprint I just created. Make sure that in the details panel of the receiver variable, you check the instance editable checkbox. Compile and you'll notice that there's now a new grayed out dropdown. Here you point to the receiver in the world. But you cannot do that from the blueprints panel because, like I said, you need to have both the sender and the receiver placed in the world first. When you place them both in a level, select the sender and in the details panel you can now point to the receiver. Now you've hooked up your reference to the receiver, you will have full access to the receiver from the sender blueprint. In the receiver, I made a function that makes the object change color. I can call this function from the sender by dragging in the receiver variable that we just created and just search for the function. Now this works well for objects that are placed in the world, but this is not always the case. How would I communicate with something that gets spawned in during runtime, for example? This is where the second way of direct communication comes in, casting. And all casting really does is it looks at the object and checks if it's of the same type as what I'm casting to. And then, just like direct referencing, you can use the blue output to get anything you want from the thing you're casting to. Now, for the magic question, what should go into this object input? To understand this, you need to know about Unreal's hierarchy. So, imagine a family tree, but instead of family members, they are made of things that exist in the game. When you're creating a new blueprint class and you see this menu, you're making a child to something in this tree. Let's say you're selecting actor, you're creating a child of an actor. So why is this important, you may ask? Well, the object you're using for the cast needs to be higher up in the tree than the thing you're casting to. Let's say you're casting to character, the object you plug into the cast can be a pawn, an actor, or an object. And if you've created an actor and you try to cast to it, the object variable type needs to be either an actor or an object. So I could use a onComponentBegin overlap event in which the actor reference is the thing that is overlapped with my blueprint. If I want to check if it was the player who overlapped with the blueprint, I can cast to the player and plug the actor reference into the object. So what's happening here is something overlaps with the blueprint and then casts to the player to check, hey, was it the player that overlapped? And if yes, the cast has succeeded, and if not, the cast has failed. If you don't know what the receiver is, you could in theory just hook up another cast after the cast failed, and another one, and another one, and another one, until you finally cast to the object that you need, right? No, please don't do this. If you find yourself doing this, please visit a therapist because you should not be doing this. If you don't know what the receiver is you're trying to communicate with, you should probably be using one of the other 2 concepts. The second concept is blueprint interfaces, perfect for one-to-many communication. Interfaces act like a wire sending a signal to any number of receivers. The receiver needs to be turned on to be able to receive the signal. You do this by implementing the interface in the class setting of your blueprint. To use a blueprint interface, you have to create an asset for it in the content browser. Under Blueprint, click on Blueprint Interface. When opening the interface, you'll notice that the event graph is grayed out. If you've never opened an interface before, this might confuse you. The only things you can do here are creating functions on the right and adding input and output variables to the function. And apart from that, this asset has no functionality. Again, this asset is just the wire between the sender and the receivers, nothing more. In the player character, on pressing E, I want to call this interact function. I can simply search for the interact function and it will appear in my nodes library now. You'll notice you still need a target. It needs to know which receiver you want to send your signal to, similar to direct communication. I will just get all the actors that the player is overlapping with whenever E is pressed, and I will use those as the target. Here I'm making a door. Implement the interface to let the signal through, and add the interact event. Now just add functionality for opening a door. Test it out and it should work. So maybe not all the actors that you're overlapping with have the interface implemented, but this doesn't matter. It will simply just ignore that actor and move on to the next one. The beauty of this system is that I can easily connect this to other receivers as well. The last concept is event dispatchers. You can see this as a mailbox or Twitter. You have followers that are listening all to one sender. This can be useful to tell a lot of actors in the world that something happened. Like an enemy has died and now a light should turn green, a door should open and a new character should spawn. Add an event dispatcher to the sender. In my case, I'm calling when the character has fully healed. Now in the receiver you can search for the event dispatcher. Bind it and you'll see that you need a reference to the sender instead of the other way around when using direct communication or interfaces. In our case, the player character is calling the event dispatcher, so we need a reference to the player character. In the LAMP blueprint, I bind the event dispatcher on begin play. Hooking this up to event begin play doesn't do anything yet, but binding just means that it's actively listening for a call from the player character. From binding it, you can either create a custom event or delegate to an existing event with the red line. In this event, you will add your functionality. In our case, that's toggling on the lamp. As you can see in the print string, I'm healing up using a debug key. When I reach 100, the light turns on, as I just implemented. As I already mentioned, you can bind as many receivers as you want to this event dispatcher, and they will all fire off at the same time. So to recap, there are 3 ways to communicate in blueprints. Direct communication, which is one-to-one and only really useful when you know who the receiver is. Interfaces, where the sender fires off a signal. You can see this as a wire, where the receivers can be open to receive a signal or just don't care about the signal. You can connect as many receivers as you want and the sender doesn't need to know what they do with it. And lastly, event dispatchers. They're useful when there's a single sender that's broadcasting to many listeners. To be able to use blueprint communication, you have to be comfortable with using variables first. You can learn everything you need to know about them in this video here. Like, subscribe, and I hope to see you in my next video.